Now let's try to understand the difference between logistic regressions and the perceptron. Because in the classical machine learning part, we have discussed a lot of things about the logistic regressions. Means that in the logistic regressions, how it geometrically intuitive, what is the mathematical formula of the logistic regressions, how you will analyze the things in the point of view of logistic regressions. Now, the motto of these main lectures is that to comparison the logistic to analyze the logistic regressions in the point of view of the neural networks, and after that we will try to understand what are the main difference of the perceptron and the logistic regressions. Let's start it. So the logistic regressions, if we talking about logistic regressions, if you remember, I request you, if you forget about the details of the logistic regressions, please go to my the classical machine learning part and then just see there. So after that, just come into that video and try to understand it. So first of all, logistic regressions, what is actually logistic regressions? So they have one input. Let's talk input. It's xi, and using it, we have predicted some output of the logistic regressions. So let's talk it. It's that yi hat. It's the predicted value. These things, this yi hat is called that predicted value of that yi. Let's write it. Predicted value of yi. Okay. Now, and what is how will get that yi hat? If you remember the yi hats, it's simple, a structure of the mathematical function. So mathematical function is like what? It's the sigmoidal functions, because that we have squeezing the value. If you remember, we have squeezing the value of that output that we come into that. Just if you forget it, just go there and see it. So sigmoid of that some weight value wi w in multiplicate of the input plus that b. If you forget, this is the actual our mathematical formulations of the logistic regression that we'll see. So okay, and here these functions we call it is a sigmoidal function. Means we are using the sigmoidal function, so squeezing the output. Sigmoidal functions. Okay, now let's take our input variable is a d-dimensional variable. Suppose I have taken here this input variable xi is belongs to the d-dimensional. Okay, now here if it is d-dimensional, suppose let's take its structure is look like that. Xi is equals to looks like that. xi1, xi2, xid. Okay, this is the structure of that input vector, is the d-dimensional input vectors. Okay, so and our data sets look like this. Suppose like d is our data sets, it's containing that input and that actual output yi, and this is the actual output and this is the predicted output. Don't be confused about that. So here what is the variable that we have here? The variable is that w and b. Okay, so for training the logistic regressions, to our main motto, we have to find for a logistic regressions, we have to find the w and the b. If we anyhow we have found that two things w and b, then we'll reach our job. So here our to train the logistic regressions we require two variables w and b. Okay, in neural network, w we call w is the weight vectors and b is that bias term. So here as well, since input vector is the d-dimensional vector, to make the multiplications of that one, w vector must be a d-dimensional vector. So w must be a d-dimensional vector. Okay, and these bias terms, so it must be a real number. Okay, I request you, please go there, the classical machine learning part, just revisit the thing, then you will understand the details how it's work. Now let's compare the things in the perspective of the neural network. Okay, if we write the thing, if we rewrite that equations in that format, then you will rewrite in that way. So these total things will be the output. So total things output, and this function, instead of the sigmoidal function, I am taking here the general functions f. Okay, and these terms, if you remember these terms, how we'll read. So suppose let's w is also a d-dimensional vector. I am using this color to more clearly understand. So suppose let's also a d-dimensional vector. So I am writing this w is equals to look like that way: w1, w2, wd. Okay, this is our d-dimensional w vector. And if we make the multiplications, how it look like? If we make the multiplication, simple w transpose plus xi, if we make it, then how it's look like? So it will be the component wise multiplications first. So it will be w1 xi1, w2 xi2, look like in that way. So it will be wd, sorry, wd xid. Okay, and one terms also we have, it's called b. So in short, if we write that thing in short using the summation term, how will look like writing? So I will be 1 to d, and this will be wi, then x, then it will be what? Then suppose instead of right, I am taking here the j, it will be better. Okay, wj xij. Okay, then it will be the beta. So here we can write the whole terms in that format, in that form, in this form. Sure, in this form we can write it here. Okay, plus these things we can take it as that our output value O. So this is the mathematical concept that already we have learned in that our classical machine learning part. What is the logistic? So now let's see in the point of view and the graphical structure. If we just represent the whole thing in the point of view a graphical one, like a neural network, then how it's look like? Let's see it. Suppose in the neural network, it's the neuron cell body. I have considered here this f. Here it's the f. So logistic, in the logistic regressions, this f will be the our sigmoidal function. Let's take different color for better understanding. It will be the sigmoidal function for the logistic regressions. This f, this is the cell body. Now we have the input for the cell body. Let's take the input is here. How much input we have? For the x1 input, they have the d features. So let's take it's that our xi input. For each xi input, the d features. So it will be xi1, xi2, look like that way, xid. Okay, and h features, this is that xi, and this is the h features, that xi. This is the first input, second features, like that way, it's the d features. So for h features also we require the w vector, and w vector is dimensional, is also the d dimensional vector. So let's take this is our the wi, sorry, not wi, only w is okay, w. So for first features, what will be the vector? What will be this? X w1, w2, like that way. This will be the wd. Okay, and one term also we required here. If you think b, and what will be the? We can write this. Please, b is equals to 1 into b. So if we consider here, this is our 1, and this will be our the bias term. Means this is the b. Okay, and if we make the multiplicative xi1 w1 plus xi2 plus into w2, and if we take it That's the input of the functions. If like in logistic regressions, it's the sigmoidal functions, and this will be our output. O. Okay, and these things, this output here, we call this output as a yi hat. This is the simple structure of the logistic regressions in the form of a neural network. Means it's called a simple one single neuron. It's the single neuron. It is a single neuron. Okay, now let's make the comparisons between these two things, this structure single and the perceptrons. How the perceptrons are makes the difference between these two things. Actually here, if we consider the logistic regressions, there are two main different things are here. So in the perceptron, instead of using that logistic regression sigmoidal functions, we are using some unit functions. So first of thing, what is the unit functions? Let's first try to understand it. What is the unit function first? So unit function is look like that. If f of x 1, if x greater than 1 and it's 0, if otherwise, means less than is equals to 0 instead of like otherwise. So this is called the unit function. So in the single neuron, if we just consider the logistic regressions is the same sigmoidal function, but in the perceptron it's a unit function. So the what is that? So instead of I just write it here, it will be better. It's that, let's call it's a different function, let's call it that fu for unit functions. So it will be that fu for perceptron, it's called the unit functions. Okay, so main difference is here, if we consider the logistic regressions, then logistic regressions take that functions activation function, this is called the activation function. So these activation functions are the sigmoidal function for logistic regressions, but for a perceptron, this is a unit function. So because the perceptron concept of the perceptron is very old, very means it's near about it's that at 1957 this concept is arising that one on that particular things only, it's that taken that unit functions, because if the multiplications means that matrix multiplication, you can think it is if it's the value is greater than 0, then it's the neuron is fired, otherwise not fired. That's the simple concept they have taken in the point of view of the perceptrons, but we will make some complexity here and to make our neural network whole deep learning chapter. So there's the main differences between the perceptron and the logistic regressions. Sure, one against, and I want to just make the summary before closing the lectures. So here, so to difference between that the logistic regressions and the perceptrons is nothing. So for logistic regressions, we have taken the activation function as a sigmoidal function, but in perceptron we have taken these activation functions as a unit functions. This is the main difference between the logistic regressions and the perceptrons, and I think you will understand and how the logistic regressions can be represented in that neural form. Okay, I think you will understand. Sure, before closing the lecture, one thing I want to remember you guys that the to train a neural network, like means what. So in previous lecture also I have told you that the for training the neural network, the main motto of the training the neural network is to make to make the to find the weight value, to find the weight value between the vertex and the is between these two different vertices. How we will initialize this? Firstly we will initialize the things randomly, we'll see when we go to the deeper, then we'll see. Firstly we have initialized that initialize the weight randomly, but how we'll adjust that weight based on our output requirement, then how we'll do that job. So the main motto of the training a neural network is that to find that proper weight between the two connections. Okay, that's the main motto. So main job of a neural network, if we just write in a single way, so like it will better, train a neural network, like its job is to make the connections or make the weights value. In short, I have written WPS between the edges. It will be better between two different vertices. Between two different. This is the main our job, that we have to find the weights between the two vertices. Okay, that's the meaning of a training in neural. I think from this video you will understand what are the main difference between the logistic regressions and the perceptron, and how we will analyze that logistic regressions in different point of view, in the point of view of a neuron, single neuron. Okay, so guys, I will see you in the next video.